we're ready to start section 5.5, which is about double angle identities. Just want to remind you, your clueless teacher at the beginning of the semester forgot to include the homework for sections 5.5 and 5.6 in the homework that was posted on the class website. So I have fixed that. There is now added to the class website, there's a separate document that's just the homework for sections 5.5 and 5.6. Also a reminder, we did 5.3 and 5.4 together in one day because they really did go together fairly well. But there was kind of a lot of homework for those two sections. There's very little homework for 5.5 and 5.6, and that was designed to even things out. Okay, so we went through those sections a little bit faster, but if you're still working on the homework and haven't completed it yet, you're not necessarily behind. You'll have less homework for this section and the next section, and that'll give you plenty of time to get caught up. Or maybe you went ahead and finished that homework and you're just watching this video a little later than you would have otherwise. Totally fine. You're on track for the class, unless you're watching this well after you're supposed to be. Okay, so what are the double angle identities? Well, let's suppose I want to evaluate sine of 2 theta. So I'm going to double my angle and then plug that into sine. Now I know that doesn't just double the sine, because if I just take a quick look at an example, sine of pi over 2 would be 1. If I double pi over 2, I get pi, and sine of pi is 0. Okay, so I want to see what this does. I'm going to just make the very brilliant observation that 2 theta is just theta plus theta. It's theta added to itself. That means that the double angle formula I can get by just plugging into the sum formula. So I might want to remind myself what the sum formula is for sine. Sine of A plus B. Remember, sines are social, so when they go to a party, they talk to the cosines. So we get sine A cosine B plus, being social is a very positive quality, at least if you're not in the middle of a pandemic. So sine A cosine B plus cosine A sine B. So I'm going to just take this formula and I'm going to replace both A and B with theta. So I'm going to get sine theta cosine theta plus cosine theta sine theta. But notice these terms are actually exactly the same, because when I multiply, the order in which I multiply doesn't make a difference. So that's just 2 copies of sine theta cosine theta. So that's my double angle formula for sine. Now, what I want you to do is find me the double angle formula for cosine. So start with cosine 2 theta. You're going to do the same basic thing. You're going to say that's cosine of theta plus theta. And then you're going to take the sum formula for cosine and plug in theta for both angles. Okay, so go ahead and pause the video, write out what you get, and then come back. Welcome back. Hopefully you remembered that the sum formula for cosine, cosine of A plus B, was cosine A cosine B minus sine A sine B. Okay. So I'm just copying that formula but replacing both A and B with theta. So I'm going to get cosine theta minus sine theta sine theta. And that's just cosine squared theta minus sine squared theta. Notice, super important that that's a negative sign. If you get that wrong and you put a plus sign there, you've just said that cosine of 2 theta is always 1. That's not true, okay? So that negative sign is super, super important. All right, now what's interesting here is that cosine of 2 theta, we've just said that it's cosine squared minus sine squared, but there are actually 3 versions of the double angle formula for cosine. So the first one that we have, let's just actually summarize what we have so far and free up a little bit of space here. So I've got sine of 2 theta, we figured out was 2 sine theta cosine theta. I've got cosine of 2 theta, we just figured out is cosine squared theta minus sine squared theta. Okay. I'm going to play around with that a little bit. Okay, so cosine 2 theta is cosine squared theta minus sine squared theta. Now, if I take a look at that, this actually involves three different trig functions, because there's the cosine, just evaluated at 2 theta, there's cosine of theta, which is getting squared, and there's sine of theta, which is getting squared. So that's a relationship between 3 different functions. I can actually, though, get it down to just 2 functions, because if I want, I could replace cosine squared with 1 minus sine squared. So that's the same as cosine squared, and then I'm subtracting another copy of sine squared. So then cosine of 2 theta is 1 minus 2 copies of sine squared theta. Now that gives me a relationship between just 2 trig functions, sine of theta, which is squared, and cosine of 2 theta. This is something that's actually really helpful when you get to calculus, because there are going to be times when you want to do calculus things. I realize that's rather vague, but we don't know calculus yet. To this function, and this function is a whole lot easier. So we're able to take this identity, because it gives us a relationship between just 2 different trig functions. Right now it's solved for cosine 2 theta. I can solve it for sine squared theta, and I can describe that in terms of a function that's a little bit easier to work with. So that's the advantage of having a formula like this. Okay. So the second version of cosine 2 theta is that it's 1 minus 2 sine squared theta. Okay. Now I mentioned that there were 3 versions, because what I did here is I replaced cosine squared with 1 minus sine squared using my Pythagorean identity. Well, I could just as easily have used the Pythagorean identity to get rid of the sine squared. So that's what I want you to do. Pause the video, rewrite sine squared. Now be careful, because there's a negative sign in front of it, but rewrite sine squared using your Pythagorean identity and come up with a third version of the double angle formula for cosine. Welcome back. So we'll have cosine squared theta minus, now I'm going to put some parentheses here. Sine squared I know is the same as 1 minus cosine squared. Now I've got to distribute that negative, so this is going to be cosine squared minus 1 minus a negative, so plus cosine squared theta, and then I can combine those like terms. So I get cosine 2 theta is 2 cosine squared theta minus 1. So 3 different versions here for the double angle formula that we have for cosine. Okay. With sine, there's really just one version, because I can't use my Pythagorean identity here because none of these functions were squared. But because with the cosine formula, I get cosine squareds and sine squareds, I've got all sorts of options for how I can simplify that. Okay. Now, if you're approaching these identities and formulas by making flashcards and memorizing, you're probably starting to feel a little uncomfortable because we keep getting more and more formulas and there's an awful lot. Don't memorize, okay? All of these formulas we got very quickly by just knowing the sum formula for sine and cosine. So I would recommend that you know those and you just practice deriving these. Every time you sit down to your homework, say, okay, I'm going to write out the 2 that I've memorized, the sum formula for sine and cosine, and then I'm just going to derive the double angle formulas. Okay, and then you'll have them, and you can use them. Okay, and you don't have to spend time memorizing them. Now, it may be that you accidentally memorize some of these. As you're doing the homework, you end up using one of these more than the others, and so you're just like, oh, I know that one, I just used it, and you remember it by accident. Totally fine. But if you know how to derive them, then if you accidentally forget them after you've accidentally memorized them, you know how to get them back. Okay, so I would strongly encourage you to do that. I'm going to end this video now. In the next video, we'll come back and we'll take a look at just using these to evaluate some trig functions.